Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And the lesson that we are going to do today is differentiation. And in differentiation, we will be doing increasing and decreasing functions today. So, increasing function. When the gradient of a function, when the gradient of a function is positive, when the gradient, so let's underline the keywords that we have here. It says it's the gradient, when the gradient of a function is positive, we say that the function is an increasing function. Or I can say it's the gradient f prime x, which should be greater than 0 as it is positive, therefore it needs to be greater than 0. Or we can say that the derivative dy by dx or the first differential dy by dx greater than 0, then the function is said to be an increasing function. It's just like whenever we have a tangent or a line, we say that whenever it slopes up, the gradient is positive and the function is said to be an increasing function because it is sloping up. So in the same manner, if we have the increasing function, then we can say that it's the tangent or the gradient of that on that curve which shall be just sloping up. Therefore, the function is called an increasing function. Decreasing function, when the gradient of a function is negative. So I have underlined the keywords here, and the keywords are the gradient being negative. I have the gradient which is a negative. The function is said to be decreasing. Therefore, I can say f prime x, which is actually the gradient. Whenever this is less than 0, the function is said to be a decreasing function. Or I can say it's the first derivative of y with respect to x dy by dx. If this is less than 0, meaning it's a negative, then also I can say that the function is a decreasing function. Or in other words, again, if I compare it with y equals mx plus c, then we know that if m is a negative, m is less than 0, then the tangent or the line slopes down. So sloping down here means that the function needs to be negative. So let's do a question here. Find the set of values of x. It's the set of values of x for which we have to find the set of values of x for which y is equal to 2x cubed minus 54x minus 1, and it is a decreasing function. So we need to find the values of x for which the function is decreasing. Therefore, the first thing to do is to find my gradient value. So if I get the gradient value, I should say that if y is equal to 2x cubed minus 54x and a minus 1, then my dy by dx here shall be equal to a 2 times 3x to the power 1 decrease, so I'll be left with a 2. Here I will be left with a minus 54, and x obviously gets eliminated. Not eliminated, but I know x to the power 0 equals 1, and minus 1 here, the constant here, it gets eliminated. So if this is a decreasing function, then I should know that this dy by dx, it needs to be less than 0. So this means that it's 6x square minus 54, and this should be less than 0 here. Or I can say it's 6x square, which is less than a 54. Or solving it, I can say that this function then is going to be x square, which should be less than 54 divided by 6. Or it's x square divided by a 9, or I can say it's x, which should be less than plus minus 3. So if this is less than plus minus 3, then I should know here that my gradient function here, that the gradient equation here, it came out to be a 6x square minus 54. This came out to be a 6x square minus 54. So this being quadratic and there is no term in x, if I just sketch the curve here, then simply I'm sketching it for the sake of understanding. It has 2 points. One is a negative 3 and the other is a positive 3. And here I can say that this is the quadratic curve that I shall be having here. And with respect to this curve, I've sketched this curve because I know that the coefficient of x square is a positive, therefore it should be the curve with the minimum turning point. So I have the negative 3 and a positive 3, and here I know for this curve to be less than 0, for this curve to be less than 0, obviously we shall be talking about this range or this set of values of x, which is from negative 3 till 3, and the set of values of x in this case now shall be negative 3 less than x, which shall be less than a 3. So this then shall be the answer to this question. So here again, a lot of understanding comes from quadratics to solve such increasing and decreasing functions. So question number 2, find the range of values of x for which y is equal to x cubed minus 3x minus 4 is increasing. So again, for the increasing function, we know that our gradient here, dy by dx, for increasing function, the gradient value dy by dx should be greater than 0. So if we have y, which is equals to x cubed minus 3x minus 4, then to find the range of values of x for which the function is increasing, first thing is to find the gradient or the derivative dy by dx. So this derivative now becomes, for x cubed, the differential here is going to be 3x squared and then a negative 3. So this is going to be the derivative, and then following the condition that I have, I should say that it's 3x squared minus 3, which should be greater than 0. So if this is greater than 0, again, I know that it is a quadratic curve, and the coefficient of this quadratic curve, is a positive. Therefore, it's the curve with a minimum turning point. So if this is the curve with a minimum turning point, solving it, I should say that this is 3x squared minus 3. I need the 2x values here. I know I'll be getting 2x values. So here I can say it's 3 common, x squared minus 1 equals a 0. Or I can say it's x squared minus 1, which equals a 0. X squared equals a 1, or x equals a plus minus 1. So on the x-axis, I shall be having two values of x. One is a negative 1, the other is a positive 1. And as the condition has said that it needs to be for 3x squared, that it needs to be the gradient which has to be greater than 0, then here greater than 0, I'm talking about this condition here which says it should be greater than 0, then it means we are talking about the values of curve of the gradient. Just keep that in mind that it's dy by dx, we are talking about the gradient here. So this gradient here, it needs to be greater than 0, and this is only possible if our x here is less than negative 1 or x here is greater than 1. So all the gradient values come out to be positive if our x is less than negative 1 or if our x is greater than 1. So this is the range of values of x for which your y function should be an increasing function. So another thing that I would bring to your notice is that we have here y equals x cubed minus 3x minus 4. So this basically is a cubic equation, and the coefficient of x cubed here, it's a positive. So we know, we have discussed earlier also, that if the coefficient of x cube is positive, it's greater than 0, then we should be having a cubic curve for which the pattern is that first it should be a maximum and then it should be a minimum. So here again, what I can see is that we have all the gradient values positive on this side of the curve, as I can see that this curve Question 3 in this lesson is taken from Winter 2014, and it's paper 1 variant 3, and it's question number 3 in the paper, part 1. Part 1 says express 9x square minus 12x plus 5 in the form ax plus b the whole square plus c, and this is for 3 marks. So this question is coming from quadratics, so we will be solving this question. So it says it is 9x square minus 12x plus 5, and we need to express it as ax plus b the whole square and a plus c. So one thing is very much obvious, and that is that we have to solve it by completing the square method, and we have to solve it such that x should be having the coefficient which is an a in this case. For that purpose, what I know here is that this 9x square can be written as 3x the whole square. Then we have a 12x, and then I should know that there has to be a constant which needs to get added so that this expression can be written in completed squared form. So what I know here is that my a value here is equal to a 3x. A value here is equal to a 3x, and b is the term which I need to find out. I have been given 2ax, 2ab, which then is equal to a 12x. So solving that, I know that a is a 3x, b is what we are supposed to find out, and this is a 12x here. So here I can say that this b can be equal to 12x divided by 6x. The x's get cancelled, and here I will be left with a 2. So this means if I add a 2 here, 2 square here, and obviously for the balance I need to go for 2 the whole square also, negative 2 the whole square also. So here I can see that the first 3 terms that I have here, 3x square minus 12x plus 2 the whole square, they are following the pattern a square minus 2ab and then plus b square, meaning here I can write this as 3x minus, we always take the sign of the middle term here, so it's going to be 3x minus 2 the whole square, and here I should be left with a 5 minus 4, or I can say it's a 3x minus 2 the whole square and a plus 1. So here this is how I should have done this question to express it in the form of ax plus b the whole square and a plus c. Part 2. Part 2 says, determine whether 3x cube minus 6x squared plus 5x minus 12 is an increasing function, a decreasing function, or neither. So they have given us this expression, part 2. In part 2, they have given us this expression, which is 3x cube minus 6x squared plus 5x minus 12, and we have to show whether this function is an increasing function, decreasing function, or neither. And we know that to describe a function as either increasing, decreasing, or neither, it's actually the gradient function dy by dx. It's actually the gradient function which is responsible to decide whether the function is an increasing, decreasing, or neither of the two. So that means here, if this expression, this polynomial, this curve equation is given to us, then I should be having the gradient equation. So to decide whether it's an increasing function, decreasing, or neither. So to do that, I should be differentiating the function, which is 3x cubed minus 6x squared and a plus 5x and a minus 12. So if I differentiate this function, then here I know that the differential equation here comes out to be a 9, 3 into 3. It's going to be 3 times 3. That will give me a 9. And then this cube gets less by 1. So I should say it's a 9x squared, and then it's a 6 times 2 giving me a 12, x square reduced by 1 giving me an x, and then I should be left with a 5, negative 12 gets eliminated. So this is going to be my differential equation, which is actually the gradient equation. So I should say this is my gradient equation, and this gradient equation will help me to decide whether the function is increasing, decreasing, or neither. So this is the gradient equation that I have. Now, if I look at part 1, then in part 1, they have actually given us the expression which was a 9x square minus 12x plus 5, and we have already expressed this function which we have over here in the completed squared form. It is 3x minus 2 the whole square and a plus 1, meaning I can take help from part 1 and I can write this equation as 3x minus 2 the whole square and a plus 1. Now this is going to be my gradient equation. So with this gradient equation, I need to decide whether it is increasing, decreasing, or neither. So what I can see here is that if I analyze this variable, which is x in this case, if I analyze this variable x in this case, then no matter what value of x I substitute here, whether it's an negative value or it's a positive value, no matter which value I substitute for x, as soon as it becomes a square here, this is a quadratic, as soon as it becomes a square here, because of the square, we can see that all negative values here also will change to negative. We know that negative square is always a positive. So it's because of this square that we are having here, I can see that each and every value of x is going to give me the answer, which is going to be a positive, and then a positive plus 1 is always going to be a positive answer. So if this is going to be a positive answer, then I can say here that this function for each and every value of x is always going to be greater than 0. So if this function is greater than 0, so what is the reason? Because 3x minus 2 the whole square is quadratic, is quadratic. So all the values of x will give us a positive answer. Will be positive here, and therefore it's this value, the gradient value, shall always be greater than 0. Therefore, this makes us decide that this given function is always going to be an increasing. Therefore, this function is always going to be an increasing function here. Let's do another question. The next question is taken from Winter 2017, paper 1, variant 1, and it's question number 2 in the paper, and it says that a function f is defined by f of x, which equals x cubed minus x squared minus 8x plus 5 for x to be less than a. So it is given that f is an increasing function. Find the largest possible value of the constant a. So largest possible value, it's very much clear that the function that is given in the question is x cubed minus x squared minus 8x plus 5, and it is an increasing function, and this function is for x to be less than a. So if this is for x to be less than a, then roughly what I see here is that if this is the value of a, then what I can see here is that all the values of x, according to the condition, they should be less than a, meaning this a then will always be the greatest value for this condition. It's always be the greatest or the largest possible value for this condition, and this is what the question is asking. Find the largest possible value of the constant a. So this is how this becomes the largest or the greatest possible value a over here. So and it's also given that it is an increasing function. So let's start solving the question. We know that for the increasing function, I shall be talking about the gradient equation or the gradient value, which should be greater than 0. Meaning in this case, I should say it's the gradient function, and this needs to be greater than 0. So if I start solving it, my f prime x is going to be a 3x square. The differential of x cube is a 3x square minus the differential of x square is a 2x, and negative 8x shall be a negative 8. So this is going to be my differential equation or the gradient equation here. This is going to be my gradient equation. This gradient equation needs to be greater than 0. So I can say it's 3x squared minus 2x minus 8, and this needs to be greater than 0. So I need to solve the equation, and to solve the equation, it's a quadratic equation. I need to factorize it. So let's see what the answer is going to be for this equation. So if I factorize the equation, then my equation here becomes 3x, and my factors are 3x squared minus 6x plus 4x, which gives me 24. 3 eighths are 24 also. So this is the factorization, the middle term break for negative 6x plus 4x, giving me a negative 2x minus 8, which should be greater than 0. It should be greater than 0 because the question has said that it is an increasing function here. So after that, it's 3x common from here. I'm left with x minus 2 plus 4 common, left with x minus 2 to be greater than 0. Or I can say it's 3x plus 4 and x minus 2, which needs to be greater than 0. So this was a quadratic equation which needs to be greater than 0. So quadratic equation, the curve is here. So greater than 0 means all the values which are above the x-axis, all the values which are above the x-axis. Therefore, with these two values here, I should say that our condition is such that all the values here, they should either be less than negative 4 by 3 or they should be greater than 2. These are the two conditions that I should be having here. So x is less than negative 4 by 3 or x is greater than 2. This is the answer. But then here the question has already suggested that this function is defined for all the values of x which are less than a, and we have a as the largest possible value also. Therefore x to be less than a, what I can see here is that actually it's this function here which is satisfying the given condition for x to be less than a. Therefore I should say that the largest possible value for a in this case shall be equal to a negative 4 by 3 according to the given condition in the question. So this then becomes my final answer for A. Let's do another question. The fifth question for the lesson is taken from Winter 2017, paper 1, variant 3, and it's question number 4 in the paper, and it says that function f is such that f of x is given as 2x minus 1 to the power 3 by 2 minus 6x. And also this f of x is for 1 by 2x less than x, which is less than k. This function is defined for these values of x from 1 by 2 till k, and k is a constant. Find the largest value of k for which f is a decreasing function. So it's clear here that f needs to be a decreasing function, and for the decreasing function, we know that our gradient function or f prime x needs to be less than 0. So let's start working on this question. They have given us f of x, which is equals to 2x minus 1 to the power 3 by 2 and a negative 6x, and it is given for 1 by 2 less than x, which is less than k. So if I need to have the gradient equation, then this is my f prime x, and I know it's a composite function here, or it's following a chain rule here, and for that I should say that it's first the power which with respect to which I need to differentiate the function. Therefore this power, with respect to this power, I should say it's a 3 by 2. The coefficient of 2x minus 1 is a 1. Therefore, it's a 3 by 2. 1 times 3 by 2 is a 3 by 2. And here I will be having 2x minus 1 to the power 3 by 2 minus 1. And after that, I should be differentiating the function, which is 2x minus 1. And then I have negative 6x, for which the differential is just going to be a negative 6. F prime x, now this shall be equal to a 3 by 2 and 2x minus 1. 3 by 2 minus 1 shall give me a 1 by 2, and then the differential of 2x minus 1 is just a 2, and I'll be left with a negative 6. So this 2 here, it gets simplified, or I can say it's f prime x, which shall be a 3 2x minus 1 to the power 1 by 2 and a negative 6. And according to the function, they have said that this needs to be a decreasing function. So if this is a decreasing function, then it means that this f prime x here, now we can talk about the first differential or the gradient equation. F prime x here needs to be less than 0. So we can take the 3 common, solving it further. This is 2x minus 1 to the power 1 by 2 minus 2, and this function needs to be less than 0. Or I can say it's a 2x minus 1 to the power 1 by 2, which can be less than 2 only. So if this is less than 2 only and I need to have the value of x, then to find the value of x, there I can see that this 2x minus 1 is to the power 1 by 2. This 1 by 2 needs to get eliminated. And to do the elimination, I should be squaring both the sides. So if I square both the sides, this gets eliminated, and here I shall be left here only with 2x minus 1, which shall be less than a 2 square, which is a 4 here. Or further, I can say it's 2x, which should be less than 4 plus 1, giving us a 5, or I can say it should be x to be less than a 5 by 2. So according to the question, they have asked us for the value of k, and I can see that this k here is for x to be less than k. So x less than k is a 5 by 2. Therefore, I can say that this k value here shall be equal to a 5 by 2, and this should be the answer or the solution to this question. The next question that I have chosen to clarify the concept or to explain it more is from Summer 2018. Summer 2018, Paper 1, Variant 3. And it's question number 8, part 1 in this question. And it says, the tangent to the curve y is equals to x cubed minus 9x squared plus 24x minus 12 at a point A. It's parallel to y equals to minus 3x. So find the equation of the tangent at A. So there is the tangent to this curve, and this tangent is at point A. And this tangent is also parallel to this line, which is y equals to minus 3x. So the word that we should be underlining here is the word which says parallel. So let's say on the curve, this point is an A. Let's say on the curve, this point is an A. And if this is the tangent to A, we have the curve somewhere, like I'm just making a very exaggerated curve here. Let's say this is the curve. Let's say this is the curve that I have here. Let's say I've just made an exaggerated curve. Let's say this is the curve at point A and the tangent that we are talking about, and this is the tangent equation that I need to find out. So if this is the tangent equation that I need to find out, then another hint that I've been given in this question is about a line which is parallel, for which this tangent is parallel. So let's say this line was here, and this is the line, the two tangent, the tangent and the line, they are parallel to each other. So this is the line which is y equals to minus 3x. So let's first analyze the line which is given to us as negative 3x plus 2. We know that for straight line, it's given as mx plus c. And as we are talking about the tangent and the tangent being parallel, then we know that the two tangents, m1 and m2, they should be equal to each other. Because when two lines are parallel, then the gradients are equal. So here if I compare, I can see that the gradient of the tangent that we are talking about should then be equal to a negative 3. So this is one thing that I can find out from this line equation, which is parallel to the tangent at point A. I have the gradient value for this tangent. Now, the only thing that is left now is to find the y-intercept of this tangent at point A. How to do that? This tangent that we are talking about is at point A, which lies on the curve also. And we know that the gradient of the curve and the tangent, they should be the same at point A. So taking help from the function or the curve equation that I have, which is x cubed minus 9x squared plus 24x and a negative 12, I can get the gradient equation. I can say that it's dy by dx, the gradient equation here, shall be equal to a 3x squared minus 9 times 2, giving me an 18x, and then it should be a plus 24. So this is the equation that I have, the gradient equation. So this is actually the gradient equation here. So with respect to this equation, if I'm talking about the tangent at A, then I know that the gradient value is a negative 3. Therefore, I can substituting the gradient value of the tangent, which is a negative 3 in dy by dx, as dy by dx we know is actually the gradient. I can see that this is a negative 3, which should be equal to 3x squared minus 18x and a plus 24. I can simplify this equation and I can say it's a negative 3 here, which is equals to 3 can be taken common, and I shall then be having x squared minus 6x and a plus 8 here. The negative 3 and this 3, they can get simplified, and I should say that this equals a negative 1, which is equals to x squared minus 6x plus 8, or further I can say it's x squared minus 6x plus 8 and a plus 1, which should be equal to a 0. And further I can say this is x squared minus 6x plus 9, which should be equal to 0. So here I can simply factorize the equation by just looking at the two end values. One is x squared and the other is 9, and I can see that both of them, x squared and 9, they are perfect squares. That means I can write them as x the whole square, and here I can say this is 3 the whole square, and in the middle I can say this is 2 times x times 3, which actually gives me a negative 6x. So this means this equation here can be written as x minus 3 the whole square, which shall be equal to 0. Or here in other words I can say it's x minus 3, which is equal to a 0, or x is equal to 3. So a, it's for point A, where my x value is actually a 3, and it's the y value which I need to find out. So to find the y value, it won't be difficult because we know that this 3, x as 3, it's present on the curve, so that on the curve the x value is a 3, and if I substitute this in the curve equation, I should be getting the y value for the function here. So in this case, what I can do is, to get the y value, I should only be substituting my x equals 3 in this equation, in the curve equation, which is x cubed minus 9x squared plus 24x and a negative 12. So when x is a 3, I can say it's a 3 cube minus 9 times 3 square plus 24 times 3, and then it's a negative 12 here. So further I can say it's y, which is equals to a 9 minus 3 square is a 9. 9 times 9 gives me an 81, plus I can say it's a 72 here, and then it's a negative 12. So this y value here comes out to be a negative 12. That means this point A here has the x coordinate as 3 and the y coordinate as a negative 12. Now, if I need to have the tangent equation, this is what the question says. Find the equation of the tangent at A. So to get the equation of the tangent at A, we shall be using our straight line equation, which is y minus y1 is equals to the gradient times x minus x1. At A, I have already said or decided that this is going to be 3 and negative 12. Our gradient here was equal to 3. Gradient here was equal to a negative 3. Therefore, substituting these values, I should say it's a y minus minus 12, which is equals to the gradient, negative 3 and x minus 3. Or I can say it's a y plus 12, which shall be equal to a negative 3x and a plus 9. Or further, I can say it's a y plus 3x plus 12 minus 9, which is equals to 0, or it's a y plus 3x and it's going to be a positive 3, which shall be equal to a 0. So substituting y as x equals 3, it's y which is equals to 3 cubed minus 9 times 3 square plus 24 times 3 and a minus 12. This gives me a 27 minus 3 squared 9, 9 times 9, 81 plus 72 minus 12. And solving it, I will be getting y equals 6. Meaning this a here shall be having the y coordinate as a 6. The x coordinate was a 3 and now the y coordinate becomes a 6 here. So to get the tangent equation, I know that this is the point A, which is there for the tangent also, meaning on the tangent I do have the A coordinates, which is 3 comma 6. I do have the gradient value, so it will be easier now to find the tangent equation. For that, I can say it is y minus y1 equals the gradient times x minus x1. It's the straight line equation. A is 3 comma 6. The gradient value was a negative 3. So the only thing that is left now is to substitute x1, y1 and the gradient value. And doing that, I shall be getting here y minus 6, which is equals to a negative 3x and a plus 9. And then further, I can say it's going to be a y plus 3x and a negative 6 and a negative 9. So y plus 3x minus 15 shall be equal to 0 is going to be the equation of the tangent on the curve at A. So this is the first part of the question. Let's go for the second part. So the second part of the question says that the function f is defined by f of x, which is equal to x cubed minus 9x square plus 24x and a minus 12. And this here is defined for x to be greater than k. K is a constant. We need to have the smallest value of k for f to be an increasing function. So again, increasing function, that means I have to have the first differential, so that the first differential needs to be greater than 0. So to get our f prime x, it should be equal to a 3x square minus 18x and a plus 24. We have found this out in the first part also. F prime x equals 3x square minus 18x plus 24, and as it is an increasing function, then I should know that this should be greater than 0. So 3x square minus 18x plus 24 to be greater than 0. 3 can be taken common, so that I am left here with x square minus 6x and a plus 8, and this needs to be greater than 0. So factorizing the equation, I can say this is x square minus 4x minus 2x and a plus 8, which should be greater than 0. X is common, so x minus 4 here. Negative 2 is common, so this is x minus 4. Here again greater than 0. So as the coefficient of x square was a positive, I can have this quadratic curve here with a minimum nature. And here I can say this is x minus 4, x minus 2. And if I solve it, then there are two values of x. One is a 4 and the other is a 2. Therefore, I can say it's a 2 here, it's a 4 here. And again, it's greater than 0. Then that means we are talking about all the values which are above the x-axis. That means it should be on the right side of 4 and on the left side of 2. So here I can say that the inequalities that I am getting here is for x to be less than 2, and here it should be x to be greater than 4. So these are the two conditions that I have here. But the condition that the question has given says that x needs to be greater than k. So if x needs to be greater than k, then I can see that it is basically this inequality or these set of values of x which satisfy the given condition in the question. So for x to be greater than k, I should say that from here it should be x to be greater than 4, such that 4 is the smallest value, and the smallest value of k in this case is going to be a 4, and this then is going to be the answer to this question. And this is the end of increasing and decreasing functions. I have tried to cover some questions from the past papers as well as some questions to explain the topic. And so in the next video, we shall be starting stationary points or the second derivative. And till then, take care and best wishes. Allah Hafiz to everyone.